Hello, everyone, and welcome to OC Live, a weekly broadcast on blockchain, branded tokens, and token economies. We feature weekly guests to discuss the latest in blockchain and the current projects that they are working on. And on this episode of today, we're going to cover Ethereum 2.0. There's been a lot of talk about Ethereum 2.0 in the community, and I figured this episode would be great to cover it. And a lot changes with the with when it's supposed to launch and things like that. So hopefully after today's episode, you'll have a better understanding of what is Ethereum 2.0, what do all the terms mean, and when can we expect it. So with us today, we have Gregory Markou. He is the VP of Engineering at ChainSafe Systems. Gregory, welcome to LC Live.
Thank you. Thanks for having me.
So apart from being a partner and VP of engineering at ChainSafe, you also teach blockchain development at one of the colleges in Toronto. So can you tell us a little bit about yourself and your involvement in the blockchain community?
Yeah, for sure. By trade, I'm a software dev. I've been doing that for about 4 or 5 years. And about 2 years ago, I got into crypto. About a year and a half ago, I actually started developing more or less on the DApp level. And then I don't know, recently in the last year and a bit, I segued right into kind of like protocol level and more low level stuff. That's kind of what I do now. I coordinate the team also at ChainSafe. ChainSafe is a dev shop and consultancy based out of Toronto. And we do a lot of open source work, especially in Ethereum 2.0. And yeah, as you said, like I teach part time every now and then. I took the semester off, but I'm a substitute right now at George Brown.
Great, great, and yeah, ChainSafe Systems is heavily involved with Ethereum. In the previous episode, we covered the Görli testnets. If you want to check that out, I'll link that down below. But on this episode, we're going to focus strictly on Ethereum 2.0. But before we get into Ethereum 2.0, let's cover a little bit about Ethereum's history and some of the upgrades that have happened in the past. So, Gregory, can you walk us through maybe some of the major upgrades or hard forks that Ethereum has undergone in the past?
Yeah, for sure. I mean, like with all the previous ones, ETH 2.0 is technically an upgrade, although it's like a code base rewrite. Um, it's a little bit different though to like old ones, like for instance, when the DAO hack happened, and we forked off and ended up having Ethereum Classic and Ethereum that we have now. And then there's always been basically the roadmap has been pretty laid out that these upgrades are going to happen. Although things changed in between because of EIPs that have been proposed along the way. And ETH 2.0 has been part of the roadmap, sharding more or less up until now. We're approaching a delayed upgrade right now, Constantinople, now St. Petersburg, I believe. Basically, we just had a bunch of little bugs along the way since November. It's bound to happen, and yeah, so um, yeah, I guess that.
Yeah, great. And then so we'll cover some of the terms that are involved in some of these upgrades. One that you just mentioned is sharding. So can you tell us what sharding is?
Yeah, so basically, if you look at like the current Ethereum, now I'm going to call current Ethereum like Ethereum 1 or 1x. If you look at that ecosystem, basically we have a limitation on the node level. Every node is required to store, like full node is required to store every transaction, which means our limitation, if throughput is what everybody's worried about, is limited to that of one node. No matter how many nodes you scale up, you're going to be stuck at whatever the throughput of one node is. So basically, the concept of sharding is to split up that state onto multiple shards, is what we call them. And basically, what that means is people running nodes on the network only have to deal with and manage one single shard. And an example of this you could think of is like, one shard might be in charge of all addresses from like 0x1 onward, another shard 0x2, so on and so forth. And as you can tell, this really separates up the state and allows for throughput to go through. So that's the basic idea around sharding and what it means. what we mean by sharding is just basically separating the state up into manageable chunks so that we can scale through the shards and move outwards that way.
Great. So it's a proposed solution to help the nodes be more process more throughput and therefore increase the transaction throughput of Ethereum.
Yeah, basically that is the idea.
Great. And then some other terms that we're going to cover is Casper FFG. Can you tell us about Casper?
Yeah, so Casper itself is basically the idea of sharding. It's sort of like the overall construct. Whereas FFG, the friendly finality gadget, was proposed by Vitalik. Contrary, you might also hear about CBC, correct by construction, which was basically proposed by Vlad. The main difference, just to cover these real quick, because I think it's important, is that FFG is trying to help transition proof of work to proof of stake, or Ethereum 2.1 to Ethereum 2, over an iterative process, whereas CBC is focused on formal methods and essentially formally proving the idea around sharding before implementing it. Yeah, so basically, yeah, as I was saying, like we're building FFG, which is Casper FFG, which is right now. And I'm sure you'll see a lot of CBC later on. We might even see a mixture of FFG and CBC, some concepts from both mix in at the end result of ETH 2.0. But right now we're focused on FFG.
Great. And I have definitely seen FFG more frequent than CBC. And lastly, we have the Ethereum virtual machine. Can you tell us about, also known as EVM? Can you tell us about the EVM and its its role in Ethereum?
Yeah, it's basically like the heart. When you run a node, you're basically playing by the rules of the EVM. So when transactions come in, for example, with smart contracts, when we execute code against a smart contract, it gets executed on the EVM. And the EVM is essentially a set of instructions, basically rules, telling the node, okay, when somebody makes an interaction with one of these smart contracts, it has to go through the subset of rules of the smart contract, and it executes it on the EVM. And if it passes, then the transaction is successful. And basically, every node in the ecosystem needs to have the same implementation of the EVM, whereas everywhere else there can be differences. But when it comes to the EVM, all the nodes, it doesn't matter who's building it, Parity, Go Ethereum, PyEVM, all of them, they all have to follow the same rules on the EVM level. Once they follow that, it doesn't matter. That's where client differentiations happen.
Great. So the EVM is basically a standard that everything has to go through.
Yeah, that's definitely one way to put it. It's just basically the rules of Ethereum on like how we execute code.
Great. And now that we got to know some of these terms that we're going to talk about, there's also some other terms that come into play with Ethereum 2.0. It's also known as Serenity. So there's some many terms involved with Ethereum 2.0. One of them is called Constantinople, another one Metropolis, and most recently Petersburg. So can you tell us about what these terms mean in terms of the upgrades?
Well, these upgrades right now don't necessarily affect Ethereum 2.0 because the way it's set up, Ethereum 2.0, we're basically rewriting Ethereum ground up, which we'll talk about a little bit later. But basically, these upgrades are network upgrades for Ethereum 1x to basically make it, live longer, last longer. So yeah, they don't play have a huge effect on the Ethereum 2.0 ecosystem. Simply just the 1x.
Great, yeah, and that's interesting, right? Because one thing that I want to cover today is how far away is Ethereum 2.0, and these upgrades are for 1x, but there are upgrades that are needed, and most notoriously, Constantinople was supposed to happen late last year, then it got delayed to January, and then they found a bug in one of the EIPs, and then now it's delayed to this month. Actually, supposed to be happening around the 28th, which is next week, and that has been called. They have added sort of a dual, like another fork to it, known as Petersburg. So I guess we'll jump into Ethereum 2.0 now. What is Ethereum 2.0?
Yeah, Ethereum 2.0 is essentially like the next kind of like the final network upgrade, or I guess the transition from the current proof of work system to a proof of stake system. That's the basic like synopsis of it. But Ethereum 2.0 is basically a massive research effort right now, as well as about eight or nine client implementers right now, just kind of like working with the researchers to better understand what it will look like, and to try and fix things along the way.
So what will be some of the benefits of Ethereum 2.0? I think two of the major ones that I have heard of is that it's potentially, or it will increase the transaction throughput. It'll be able to handle more transactions, and another one is that it will be more energy efficient. Can you tell us about some of the benefits and how it will achieve this?
Yeah, I mean, those are definitely the two main ones. Basically, as I was talking about earlier, in regards to throughput, because we're splitting up the state into multiple sections, what we're doing is we are actually. I'll start with energy efficiency because it'll lead in better. Basically, we're going to be significantly more energy efficient because the existing proof of work algorithm requires really expensive computations to determine the chain state. And that's why you have a lot of GPUs running, and the GPUs obviously are very like scoop up a lot of energy, and that's where you always hear about the, you know, blockchains cost too much energy and they're really bad for the environment. Proof of stake differs because what happens is people become validators on the network, and they stake. So in our case, we're staking 32 ether. If you have 32 ether, you stake it, which means you lock it up and you can't use it. You become a validator on the network. And what that does is it means that you're in charge, you'll get randomly in charge of like one of these shards that I was talking about earlier. And basically we rotate and we randomly select validators to validate shards. And that's basically will segregate everyone into shards, and transactions will funnel into those shards, therefore increasing our throughput, because we don't have to rely on on a single node taking all the transactions. Now, in this case, we have them individually. And the reason this is energy efficient is because this actually doesn't require extensive computations. What it actually requires is a group of validators, let's call it 100 just for sample size, would be assigned to a shard for a certain period of time. And those validators, we need about 2/3 of them to all agree on the state of that shard. So each shard essentially has its own like blockchain. You can kind of think of it that way. It has its own chain state. And basically, once if they every block they validate, say, hey, yes, this is like what I believe the current state is. And if you get 2/3, then we succeed. Then the block gets added. And basically, we take those headers and move it up. But again, we can talk about that a little bit later. But yeah, that's sort of how it's more energy efficient because we don't actually require the heavy computations anymore. What we do require is just like the honesty in the validators. And we have stuff called slashing conditions, which will basically remove stake from validators that act nefariously. So for instance, if 1/3 of the validators of a shard disagree with the other 2/3, that 1/3 would then get a penalty and lose some of their stake.
Good. So does this also change what a miner would need to use in order to mine Ethereum? So it would be less energy used from the miners.
Yeah, completely different game park. So basically, the idea is because it's so computation light, uh, basic commodity hardware should be able to mine on Ethereum and be very efficient at it. In theory, that you could potentially validate off of like a phone. I know there's one of the implementers are working on that, making it mobile friendly. So that's really exciting because it basically opens up the opportunities for everyone.
Yeah, that's definitely very very exciting. Because you don't have to have thousands of dollars invested in GPUs and mining hardware. That definitely opens it up to more people.
Oh
Um,
yeah, like you could probably get away with, Raspberry Pis might be able to like be a validator node, for instance, on the network.
Great. So maybe we'll see like an increase of users that aren't miners, like everyday users, try to implement try to mine. Earlier you mentioned that that each shard is sort of like its own blockchain, and I think this is where the beacon chain comes in. So Ethereum 2.0 is split up into three phases, and the first phase is called phase zero, and this is where the beacon chain comes in. Can you tell us about the beacon chain?
Yeah, so that's what we're working on right now. The spec is almost done for it. We're just kind of making minor tweaks to any bugs that arise and things like that. But basically, as I was saying before, every shard has its own chain, so to speak. And what we do is we take the headers after a certain amount of period of time from the shard chains and propose them to the beacon chain. And basically, the beacon chain keeps track of, similar to how like you could think of like a beacon block. It has its own beacon block, and it contains basically a bunch of transactions, as you could think of them, but they're actually shard headers. Um, and it basically, that's how we keep track. So the beacon chain keeps track of all the shards, keeps them all in sync, and it's also in charge of basically rotating the validators and telling the validators, hey, you need to go, deal with shard 0, shard 2, shard 3, so on and so forth. So the beacon chain is sort of like the overseer, and then all of the shard chains underneath are the ones that deal with the transactions. So the
Great,
beacon
great.
chain does not deal with any transactions. It simply just conglomerates all the shard headers.
So it's almost like it's a master sheet, and it has all of the headers in the beacon chain, and then beneath that or off to the side is each individual shard.
Great example. That's exactly how it is. It's sort of the master sheet. Yeah. And basically, we assume all beacon blocks have reached finality, which basically means that like that is the exact state, and that like once it's reached the beacon chain, that we can assume the shard state is that is the state, and it is final.
Great, and now we'll move into phase one, which is shards without the EVM or without the Ethereum virtual machine. What does this mean? What does a shard without the EVM mean?
Yeah. So basically, in the beacon chain, in the current phase 0, we don't actually have shards. So what we're doing is we're just assembling like empty beacon blocks, so to speak. In phase 1, we implement the shards and the shard chains. But what we don't do is we only allow them to essentially. It should be only sending transactions. I believe in the last talk I heard, they do want to incorporate that. And basically, that just means we'll only be able to send transactions back and forth on these shard chains. Uh, Otherwise, it would just be empty shard chains, and then we'd be proving the headers upwards to the beacon chain. So that's what it means. Without an EVM, we basically can't do many computations, because, as I said before, it's kind of the rules, right? And if we don't have the rules laid out, we don't really have we can't really process like smart contracts, for instance. So in phase 1 and 0, there would be no smart contracts whatsoever, and we can probably expect to see some transactions going through.
Great. So it's until phase two where you are able to have contracts.
Yeah. So in phase 2, we should have the EVM. It's most likely going to be an eWASM, which is essentially WASM is WebAssembly. It just makes it so that, without going too detailed, just what WASM makes things it makes it easy to execute on basically any machine. And eWASM is essentially just Ethereum WASM. So we're just making eWASM as our EVM layer. And then at that point, we have our full ETH 2.0 implementation. Obviously, there will be further network upgrades similar to how we see in Ethereum 1 right now. But we should be full-fledged. That would be the utmost. We'll be acting similar to the Ethereum 1 because you'll have smart contracts. You will start seeing dApps start migrating over, etc.
Great, and then also part of phase two is shard cross shard communication. So What does cross shard communication mean?
Yeah, so this is like the weird, kind of like a weird concept to grasp, but because all the trends, like for instance, my example earlier, let's say all addresses 0x1 are on shard one, right? Basically, the idea is that they're stuck on that shard. They can't make, for instance, if a smart contract got deployed to shard one, how are you gonna interact with a smart contract on shard two? So we have this concept of cross shard communication, which will allow us to make interactions from one shard to another shard to multiple shards. Which it's a bit of a challenging feat. I don't think there's anything super formal on that right now. There might be a few posts on ETH Research that are covering that, but it's probably one of the more challenging aspects that we're going to face. The researchers are going to face, and definitely when we come to implement it.
Great, great, and that's sort of one of the last pieces to put it together for it to be finalized. So you said you're currently working on the beacon chain, and there's three phases. So what are the timelines of each phase?
Yeah, so basically we're there's a couple like bunch of different factors involved here. Basically phase zero is just starting to be more finalized on a specification level. The reason for it is because uh, we implementers sort of jumped the gun. Researchers didn't really ask implementers to start yet. We started, and now we're kind of working with them. So it's a little bit delayed, but we can start expecting to see single node testnets hopefully end of March, which basically means like if it was our implementation, the idea is hopefully we can start seeing like a bunch of our implementations just talking to each other and syncing empty beacon blocks. Hoping to see cross client implementations more in the spring, and maybe beginning of summer we'll start seeing. We could see like spring, see the test nets start spawning maybe with multi client, and then if all goes well in that time period, you could see like maybe early summer, midsummer we could see a hopefully go live mainnet. Although there is some talks that happen closer to September, maybe in the fall. It all depends on how the spec moves and how the implementations move along in that process.
Great. So has this been delayed? Do you expect this to be delayed? What have been some of the major challenges towards development?
Yeah, I mean, for us, for our team specifically at ChainSafe, one of our biggest challenges was that we were always behind and we were always playing catch up. So we basically started to checkpoint the specification and basically just like we're just gonna at this like date is the only time we're gonna deal with. We're gonna make it up to date to this date and not look at the other changes. Since then, we started getting releases happening on the specification, which really helped us out because every week they do a release versus like multiple times per day. There was like changes being made. So that was one really big challenge. Another challenge, I guess, is due to the languages that we're using. So lots of different teams are having troubles, especially around like numbers. It sounds a little funny, but every language has its own basically boundaries on the size of the numbers, how the numbers are represented, so on and so forth. And basically, we're writing it in JavaScript, which sounds a little crazy, but it is. But the challenge of that is very good. It's good for tooling, but it's really bad for numbers. We don't have certain concepts, and our numbers are maxed out to a certain degree, so we have to use like supplemental libraries, which makes it a little bit slower and unideal. Um, but aside from that, like just getting people to understand what we're writing, keeping up with the constant changes is definitely one of the more challenging aspects. But it's very manageable.
Great. So ChainSafe is one of the teams working on Ethereum 2.0. What are some other either teams or communities that are also working on this?
Yeah, I don't want to miss anybody, but I'll try and list them all off. We have Prismatic Labs. They're kind of one of the first teams to get out the gate. The Nimbus team. We've got Consensus has their own team through Pegasus. We got a couple individuals like the Swift implementation called Yeeth. Um, Java, Python. Python's being written by the researchers mainly. Yeah, the Lighthouse is also another implementation. And Parity is building one, I believe, in Rust. There's lots of implementations. There's also lots of like different POCs people are building of certain aspects. For instance, someone recently we have this this feature called LMD Ghost, which is part of our fork choice rule. And there's been a few people working just only on that, on like making different implementations of it. So there's lots of different people helping out in the ecosystem for ETH2O and helping on different areas of it. Some people are just working on networking. Like for instance, we're using libp2p right now, which is written by Protocol Labs. So there's a lot of different aspects here and a lot of different players. And there's something we should know is there's a bunch of different pieces of software too. There's the beacon chain software, then there's also validator software. Because you can either be a validator or you can also run a beacon chain. But as it states right now, I do not think you need to run both. You can run one or the other. Yeah, so there's lots of players right now.
Great, and then this might be a little hard to answer, but how far do you think we are from Ethereum 2.0? From the 3 phases being completed, do you see this happening 2 years from now, 1 year from now?
Yeah, basically, like Ethereum 2.0 we will start Ethereum 2.0 live mainnet after phase 0, because technically speaking, it fulfills the requirements. It also adds finality because how it works is we're basically just we have a deposit contract on the mainnet on Ethereum 1 that's how you register as a validator. Ethereum 2 the beacon chain will look at that contract, add you as a validator if you deposit 32 ETH. And as soon as phase 0 is done, we're basically that functionality will exist and we will be syncing empty blocks. I foresee a fair amount of people to be joining in at that point. And as I said, like summer this year, maybe fall this year, we can see that actually happen. Phase 1 and phase 2 the specifications have been getting rolled out fairly quickly. And there's good research happening. So, if I would be optimistic, maybe to say 2020, like mid 2020, late 2020, to have all 3 phases done and live.
Great, and going back to transaction throughput for a second, how many transactions is Ethereum 2.0 expected to be able to handle, and how does that compare to what Ethereum is able to throughput today?
Yeah, somebody actually just updated the math on this recently in the sharding getter. But basically, if you can think of, I don't have the number exactly off the top of my head, but it substantially. Because if you want to think about it this way, I believe there's about 1,000 shards. I could be a little off on that number. Could be way more. But basically, every shard, assuming every shard could handle, like, let's say 100 transactions per second, 50 transactions per second, even 10 transactions per second. You multiply that against 1,000 shards. That's like 10,000 transactions per second that we could technically see going through. So basically, it's a factor of how many shards are being run and what the shard throughput. Where currently, as I was saying before, because we're limited to what a single node can handle, the current transactions per second, I think it's around 7. I'm not mistaken. It's about 300 transactions we can squeeze into a block.
Great, and that'll definitely help bring Ethereum and all the applications built on Ethereum to the next level. And what should people do, whether it's a miner or whether they're Ethereum clients? Is there anything they need to do when these upgrades happen?
Yeah, so if you're a traditional Ethereum 1 miner, you'll basically have to download new software. You'll have the option of running either a beacon chain or a validator node software. And basically, if you want to be like the equivalent of a miner on Ethereum 1 in ETH 2.0, you'll need to basically be a validator. And you can run as many validators as you have 32 Ether. So if you have, 320 Ether, you can run 10 validators. And basically, yeah, like you can either abandon ETH1 entirely. It'll still be running at the same time as ETH2 for a fairly long time before it becomes fully deprecated. And ultimately, the community just has to stop mining on it. But in order to be a miner, so to speak, which we're not really calling them miners, more or less we're calling them validators, you just need to run new software. And it's the software we're building.
Great, and moving on to sort of something that I saw in the community is some Ethereum developers or some developers in the space have concerns of potential lack of funding from the Ethereum Foundation, because this isn't, this is a development towards building something that's it's not, it's not a business, right? Like there's no money getting generated for the teams individually. Rather, it's usually through grants. So, in your opinion, what can the Ethereum Foundation community do to help further the development of Ethereum?
Yeah, so grants is definitely a tricky question. But basically, what the community can do is they can help fund projects. Gitcoin has a bunch of, almost, I think all the implementers are on Gitcoin. Basically, you can give like monthly subscription to just kind of give a little bit of money just to the implementers to help them bootstrap. $5 is five DAI, for instance, is better than nothing. Now with the Ethereum Foundation, it's a little tricky. I mean, like I believe they only rolled out their grants program like a year ago, maybe a year and a half ago. And I do believe that we should be careful with this money because we also need to be maintaining Ethereum 1. So we can't just be giving money out to left, right to every implementer. I think we need to be. I think they're being careful and wise about it, in my opinion. Basically, people that implementers that should have to prove themselves first that they're like committed, that maybe after phase 0, we can start seeing some grants come out to help them out. I think that's more realistic in my opinion. It shows, who's dedicated and who's not. Although at this point, I think like all the implementers are very dedicated to it. But like for us, for instance, we do fund some of it through our consulting side of the of ChainSafe, as well as we have quite a bit of funding to get us through probably the next couple months, with fairly growing our team a bit. So we do have some external funding, but also if that does run out, and we're happy to continue funding internally. Although ideally, grants are best case scenario here. So I don't think it's really a lack of funding. Rather, we should let the development get a little further ahead before we start fully funding. And most of the teams are funded well enough to get them through most of this year, which I think is good enough for the time being. Let's see how everyone does, make sure everyone's still committed, etc.
Yeah, hopefully there's something, definitely seems like we're fine this year, but hopefully there's something that can be better built for the future. If a grant would ever stop, it would suck if a development team would run out of funds. But I guess this leads to the end. I guess all I have left for you is if there's any developers out there that want to get involved with Ethereum 2.0, or if it's just the community, where can they go to learn more?
Yeah, it depends on what side you want to be on. If you want to be on the research side, ETH research is probably the best spot to go. If you want to be on the development side, I'd start maybe with learning kind of a bit about Ethereum 2.0 if you don't already know. Check out the Gitter, the sharding Gitter. That's where we all communicate, kind of get vocal. Finding a team based on the language. For instance, that's why ours is in JavaScript. Pretty accessible language. There's Go, Rust, Python, Nim. There's tons of languages. So if you want to try and implement, I would highly advise going to a language choosing that client, checking out their issues. Yeah, I know ETHUB has a really good listing of like all the implementers, repos to their social medias, etc. So that might be a good place just to kind of like get a idea of like what the teams are and where the teams are out there. But yeah, I would just pick a language that you're good with, dive into it that way, check out their issues, see how far along they are, and chat with them. Most teams have their own Gitter as well, so it's a great place to start.
Great, and I'll go ahead and add that link to Gitter and Ethereum research down below in the description. For those of you that are watching this live, thank you for joining us. I hope you learned a little bit about Ethereum 2.0, the timeline, and what you can expect, and a little bit about how it works in terms of development. And Gregory, thank you so much for joining us on OC Live today.
Thank you for having me. It was great.